Hello, everybody. Happy Monday. So, last week you did a lot of work with maybe not a ton of feedback. So, hopefully, you feel like you're caught up. Okay. Um, the finding trig connections is where I'd like to be right now. If you have questions over the other worksheet that I gave you on Thursday, I posted that key on Friday, and I'll the rest of the key with all the work that I did originally was covered up just because I wanted you to be able to check your answers. But I'll show you. You should have that key available now, where you can see my step by step. Okay, so if you have any questions about that, feel free to reach out to me. So just a quick look ahead at our week. It's scheduling week for in-person learners, so our classes are only 35 minutes. So we won't have a ton of extra time to do work in class and stuff. So today is our last big day of notes. Tomorrow we'll kind of do some in-class work. Wednesday will be a test review day. Thursday will be a test review day. Friday will be part 1 of the test, and next Monday will be part 2 of the test. Again, it's not because the test is super long, but it's because Friday's class is only 35 minutes, and that's not exactly a ton of time to take a full test. Okay, we haven't actually had a real test yet this year. I don't try to crush you guys on the test or anything like that. I feel like they're pretty fair. I give you some test review to do. That's not exactly like the test, but it should point you in the right direction for the test. I'm going to ask that you guys zoom in on Friday and Monday to take that test with us, and then you'll take a picture and submit it just like normal. Okay? So today, I want to talk about this finding trig connections paper that you guys turned in for me already. I appreciate you guys doing that. So what we're going to do is we're going to start talking about some trig identities. Okay, an identity is going to be like a rule that we know is true for any angle theta that's on the unit circle. Okay, now what I'd like you to do is by the end of the year, over the next couple months, we're going to be adding to our trig identities, and eventually we're going to have somewhere around 20-ish trig identities. So I would like you to have a separate page in your notes that has all your trig identities on it. Okay, so it could be on today's notes. You could just pick the back page of your notes or something like that, but somewhere where we can add to it, you know, a little bit at a time. So today we're going to end up with 6-ish trig identities, something like that. And then next chapter, maybe we'll add 5 more. And then the next chapter, we'll finish it up. But I want you to have one place with all of them. Okay? So again, identity is just a pattern that we find, a rule that we can follow. So let's look at the top section. So questions 1 through 9. So which ones did we find that were the same? So I found that number 1 is the same as number 8. Did you guys find that? So you don't have to write this down because this was already on the worksheet. So just listen. So sine of pi over 3 is equal to negative sine of negative pi over 3. Okay, did you guys find that? Okay, now our goal is to be able to kind of think, is this going to be true for any angle, right? We know it's true for pi over 3 because we know the values, but is this always true? Well, let's draw a little generic picture here. So here's angle theta. It could be any angle, right? So what would negative theta look like? Well, negative theta would just be down here, right? In the 4th quadrant. So if this is positive theta, negative theta, we opened up this way. So tell me about the y values here, because remember, sine is my y values. So what do you notice about these y values? Well, the y values are going to have the same value, but opposite signs, right? like sine of pi over 3 is radical 3 over 2. Negative sine of negative pi over 3, well, this would be negative radical 3 over 2 would be this y value. And so we know these are equal because the negative of negative radical 3 over 2 is equal to positive radical 3 over 2. Okay? And so this is our first identity. Our first identity tells me that sine of an angle, any angle, is equal to negative sine of negative theta. Okay, so summarize what this means for me. If I have opposite angles, then the outputs are also going to be opposite. Okay, that's what that's telling me. So if I have like sine of pi over 4, I know that that's going to be equal to negative sine of negative pi over 4. Okay, and that's because of this picture here. If I have opposite angles, I'm going to have opposite y values. That's what that means. All right, there's your first trig identity. Congratulations, you found one. All right, let's find another one. All right, so back on my worksheet, I noticed that number 3 and number 7 were the same. So negative tangent of 5 pi over 3 was equal to the tangent of negative 5 pi over 3. Okay, can I draw a picture that would help me understand this one? Well, let's see. So negative 5 pi over 3, that puts me in the first quadrant. Positive 5 pi over 3, that would put me in the fourth quadrant. We know they're both over 3, and so they have the same tangent value, but this has positive slope, this has a negative slope, which means their tangent values are opposite signs. So that negative out in front allows me to say that these are equal to each other. So how can we turn this into a more general rule here? So I think it looks kind of similar to this guy over here, right? If we have tangents that have opposite angle measures, that tells me that their values will also be opposite, okay? And we can do another example here, like tangent of pi over 4 compared to tangent of negative pi over 4. So here's pi over 4. The tangent of pi over 4 is 1. Here's negative pi over 4. The tangent of that is negative 1. So they have opposite signs, okay? So there is my second trig identity. So tangent of theta, like tangent of pi over 4, is equal to the opposite of tangent of negative theta. So if we have opposite angles, we're going to have opposite outputs. That's what that means. Okay? All right, so 2 down, few to go here. Okay, next one I see that were the same was 2 and 6. Did you find that 2 and 6 were the same? So cosine of pi over 3 is equal to cosine of negative pi over 3. Now, how is this possible? Well, let's think about pi over 3 and negative pi over 3. Or we can make it more general, theta and negative theta. Think about cosine. Cosine are the x values here. Well, what do you notice about those x values? These x values are the same. So it doesn't matter if it's a negative angle or a positive angle. The x value of that is still going to be the same. So what's our identity look like? Well, it's almost like these, but it's a little bit different. It's going to say cosine of plain old theta is equal to cosine of negative theta. Okay? So it doesn't matter if the angle is positive or negative. The cosine value is going to be the same. That's what that identity is telling us. Okay, down towards the bottom of the page here. Did you find that 10 and 15 were the same? So sine of pi over 4 over cosine of pi over 4 was equal to tangent of pi over 4. Now this one, maybe not as shocking, okay? But let's see if we can figure out why this is true. So tangent of pi over 4, let's compare that to the sine of pi over 4 compared to or over the cosine of pi 4. Okay, now forget about the values for a second. Tangent is what? You know that tangent is y over x, right? The y value divided by the x value. Sine is always equal to the y coordinate, and cosine is always equal to the x coordinate. So it makes sense if tangent is y over x, and I have sine over cosine, that would be y divided by x. It makes sense that tangent would be equal to sine over cosine. And that'll be true anytime that we feel like this. So I'm going to draw just a little line across. This is kind of like a separate category. And my fourth trig identity is tangent of theta is equal to the sine of that angle divided by the cosine of that angle. That'll be true for any angle that you want to throw in there. Okay. Now let's keep rolling here. Did you also find that 11 and 13 were the same? Okay. And if this makes any sense at all, then 11 and 13 being the same, that shouldn't be too shocking, right? Think about cosine of negative 4 pi over 3 divided by sine of negative 4 pi over 3. So cosine, remember, is the x value of that angle. Sine is the y value of that angle. Cotangent, what do we remember about cotangent? Well, cotangent is 1 over tangent. So it's 1 over y over x, which is equal to x over y. We're just taking the reciprocal. So it makes sense that cosine over sine matches up with cotangent. Okay, so that's going to be my fifth trig identity. Cotangent of theta is equal to the cosine of the angle divided by the sine of the angle. Okay, so we got 5 so far. Let's go ahead and flip it over. We have 3 to go, and then we're done for the day. Okay, so on the back here, number 16 matches up with number 21. Did you guys find that? So sine of pi over 3 is equal to the cosine of pi over 2 minus pi over 3. Okay, now, do you see a pattern emerging here? Can you maybe start even picturing what our next identity might be? What's the connection here? If I have sine of an angle, that's going to be equal to cosine of pi over 2 minus that angle. Okay, now why is this working? What's going on here? Well, this is actually what's called one of our complementary angles identities. You remember what complementary angles are? Complementary angles are angles that add to pi over 2. Okay, so what this is saying is if I have the sine of an angle, that's going to be equal to the cosine of the complement. Okay, let's think about what that would look like as a picture. So here's pi over 3, right? Sine of pi over 3 is radical 3 over 2. What would the complement of pi over 3 be? Remember, complementary angles are two angles that add to be 90. So the complement would be this angle right here. I can see it, right? It would be the angle that pi over 3 plus y equals pi over 2. So it's this angle right here. Well, how big is that angle right there? Well, that's going to be pi over 6, okay? And we know that the sine of pi over 3 is radical 3 over 2, and we know the cosine of pi over 6 is also radical 3 over 2, okay? And that's going to be true for all of our angles. It's called the complementary angles theorem. So how can I kind of summarize this? I'm going to draw a line because this is a separate category. So sine of some angle is equal to the cosine of pi over 2 minus that same angle. Okay, that's one of our complementary angle identities. So where does it come from? It comes from the fact that if this angle is pi over 3, the other angle that's missing is pi over 6. We know when we write our coordinates, we go 1, 2, 3, 1, 2, 3. It makes sense that my x and my y values are flip-flopped on the top coordinate and the bottom coordinate. And that'll work even if it's not nice, pretty, and neat pi over 3 and pi over 6. That'll work for any angle theta. Okay, now we'll stay here. Did you see that number 18 matched up with Oh boy, I lost it. Number 22. Do you guys see that? 18 and 22 are the same. Oh, that's not true at all. Yes, it is true, actually. Sorry, I read that wrong. 18 and 22 are the same. Okay. Cosine of pi over 3 is equal to the sine. I'm struggling. Sine of pi over 2 minus pi over 3. So do you notice the relationship here? It's almost the same as that. What is it saying? The cosine of this angle is equal to the sine of its complement. Okay? The cosine of an angle is equal to the sine of its complement. So the cosine of theta is equal to the sine of pi over 2 minus that same angle. Okay? The cosine of an angle is equal to the sine of its complement. Okay, how many do we have left? 1 to go. Okay, now this one is the most important. So if you tune me out, tune back in for a second. Okay, so this one, I don't know if you guys noticed, but 17, 20, and 24 were all the same. Okay, what was it? They're all equal to 1. Okay, there's got to be a reason for this. So let's take a look here. So it's sine squared of an angle plus cosine squared of an angle equals 1. That happened every time. 17, 20, 24. We had sine squared plus cosine squared equals 1. Did you guys get that every time? Or number 24 is cosine squared plus sine squared equals 1. Did you guys get that? So that's the identity. So let's write it down, and then I'll tell you why it happens. So sine squared, or maybe if you want to do cosine squared first, I think that's more common. You'll see that in textbooks. Cosine squared plus sine squared equals 1. Now that's interesting. Any angle, if you take the sine of that angle and square it, plus the cosine of that angle and square it, and you add those together, for any angle on the unit circle, it'll always be equal to 1. How is that possible? Well, there's a couple ways that I can show this to you. Okay, so let's start by drawing generic right triangle. How many times have we drawn this generic right triangle? It seems like a million. So this is a right triangle. How big is the hypotenuse right here? If this is the unit circle. That's a pretty good circle. Nice job, Mr. Cridge. How big is the hypotenuse? The hypotenuse is 1. How do you know? Because it's the unit circle, the radius is always 1. Okay. Okay, what next? Oh yeah, remember we said if this is the coordinate, then this is always the x, and this is always the y. Do you guys remember that? Of course you do. Nice job. Okay, remember, this is the x distance, this is the y distance. My coordinate is x, comma, y. Okay, now, this has a very special name to it. It's called your Pythagorean identity. Okay, Pythagorean identity, interesting. Do you have something else that has the word Pythagorean in it? Yes, you do. What is it? It's called the Pythagorean theorem. Do you guys remember that? What is the Pythagorean theorem? It says that a squared plus b squared equals c squared. You guys remember that? Of course you do. Okay? Apply that to this triangle here. What is that going to look like? It's going to look like x squared plus y squared equals 1 squared, or 1. Whoa. First of all, mind blown for a second here, especially if you're in the ACT prep group. I know I talked about this. What is this? This is the formula for the equation of a circle. Whoa. So we just found the equation of a circle by doing Pythagorean theorem. A squared plus b squared equals c squared, x squared plus y squared equals 1, because it's a circle. Wow, that's interesting. Okay, now let's take it a step further. X is equal to cosine of the angle. Y is equal to sine of the angle. So let's do a little substitution. Instead of the letter x, let's write cosine. Cosine squared of theta plus, instead of y, let's write sine. Sine squared of the angle equals 1. Boom shakalaka. There's my Pythagorean identity. Okay? This means for any angle on the unit circle, if you square the cosine value, you square the sine value, you add them together, you will always get 1. That'll happen no matter what. Okay? And why? It's really because of this equation here. Any point that you want to pick. You want to pick 2 pi over 3. What's your coordinate 2 pi over 3? That's negative 1/2, comma, radical 3 over 2. If you take the x value, negative 1/2 squared, that's 1/4, plus the y value, radical 3 over 2, squared, that's going to be 3/4. You add those together, boom shakalaka, you get 1 every time. Okay? That's kind of important. He's called the Pythagorean identity. Okay? Give yourselves a high five out there. Nice job. Okay. So here's what we're going to do tonight. Your homework is to make sure that this paper is wonderful. Your homework is to make sure you have these identities in a nice, neat location where you will never lose them. You promise me you will always be able to find them very quickly. Okay? Your homework is not to do any worksheet tonight. Okay? Tomorrow in class, we are going to do that worksheet together with your peers that are in person. Okay? So you have no homework to turn in tonight, but come to class ready to go. We're going to start working with some of our identities in class. You will not live Zoom. I'll have another video for you tomorrow, kind of going through some of those examples with you. Okay? Remember, test on Friday and Monday. Our next Gobble quiz, you took one today. I'm sure you did wonderful. Our next Gobble quiz will be on Wednesday. Okay? And I'll send out more information about, not Wednesday. Did I say Wednesday? It's going to be on Thursday. I don't remember what day I said. Not Wednesday. It'll be Thursday. Will be our next Gobble quiz. Okay? More information coming on that. All right. Thanks for listening, everybody. I hope that you have a great rest of your Monday, and I'll talk to you guys soon.